Hello and welcome to this lesson on specific heat capacity. Please date it here. Just to give you a little view of where we are. So we've been working through this energy unit. You just had energy 1 test, and now we're just going to start on the second part of energy 2, as I call it. So please date it. So we're going to look at a new concept now that you might not have covered before: specific heat capacity. So I will know what is meant by specific heat capacity. I will know how to use and rearrange the formula delta E equals mc delta theta. That's what this symbol means, the triangle delta E. And I'll know when to apply the formula delta E equals mc delta theta. Just simply, I'll mention it now, I'll mention it again. Delta just means change in. So delta E in this one means change in energy, and this delta theta over here is change in temperature. So let's start off with just a little question. If you had 1 kilogram of water and 1 kilogram of oil, and they're heated with identical beakers using identical Bunsen burners, which will reach 90 degrees first? Okay, so just give yourself a bit of thinking time. Pause if you want to, and just think what would you say? How long do you think which one will get there first? Give yourself some thinking time, and then I'll come back in 5 seconds. 4, 3, 2, 1. Okay, well, you've obviously made a decision. Well, the answer is, even though oil can actually go up to quite a high temperature before it changes state or burns, actually water would actually takes more energy to heat it up. So which will reach 90 degrees first? Well, it will actually be oil. And the reason it's oil, well, I suppose the reasons might be a little bit more complicated than what I'm going to say, but the one thing is I want you to appreciate is that different substances take different amounts of energy to help them to make them change their temperature. And actually, water takes quite a lot of energy for it to change its temperature. It's actually, how we would say this, it's got a very high specific heat capacity. Now, if I was in the classroom now, I would be showing you a nice little demo. If you want to see this demo, just type in balloon burning candle trick or just balloon burning candle on YouTube, and you can see a demonstration of this trick. What it is, if I was in the lesson now, I would have a balloon and I'd hold it above a candle, and what would happen is that the balloon would burn and pop as soon as you brought it close to the candle. Then I would produce another balloon that looked identical, and I would hold it over the candle, and if it goes well, which it normally does, sometimes it doesn't always, but if you hold it well, there's a second balloon doesn't pop. And the reason is because in the balloon, the second balloon, I put a small amount of water in the bottom of the balloon, and in effect what happens is that the water absorbs the heat, stopping the balloon from actually burning, stopping the temperature. So even though you can hold it quite close, so you can hold the candle quite close to the balloon, and even though the candle's very hot, most of the heat goes straight through the balloon and into the water, and the water just absorbs that heat. And that's because water is actually very good at absorbing heat. So that's something, if you've got a nice little tea candle, you can have a go in a couple of balloons. You can have a go at that at home if you wish. So the point is that water has what we call a high specific heat. And fundamentally, that means it can take a lot of energy before it starts to raise its temperature. So let's get off with a definition here that you need to know so that you can write this in full in your booklet. What is specific heat capacity? It's the energy required to increase the temperature of a mass of 1 kilogram, or we could call it a unit mass, that's probably a better way to say it, but we can just say 1 kilogram for now, by how much do you think? By 1 degree C. It's the energy required to increase the temperature of a mass of 1 kilogram by 1 degree C. And the SI unit, the base units that we'd use for that are energy, joules per kilogram per degree C. So really, if I tell you the specific heat, then you know how much energy for a substance that you would need to get 1 kilogram of that to increase by 1 degree C. Now, some values down here. Water, it's got a reasonably high one, 4,200. Air, 990. Copper, 390. Iron, 450. Concrete, 3,400. Cotton, and aluminium, 920. So if you get those values down, put them in your booklet. You can see water quite high. Metals, even though they're very good conductors of heat, as we'll see in future lessons, they don't actually take as much energy as water does to actually increase its temperature. So metals, when you heat them, their temperature will increase relatively quickly compared to something like water with a high specific heat. So the old triangle that I'm sure you've seen, you're used to by now. We have seen 1 with 3 on the bottom before, which was E equals mgh. This is E, M, C, and delta theta. What do these stand for? Well, the E is energy, it's in joules. M is mass, and that's measured in kilograms, it's the SI unit. As we've just looked at now, specific heat is joules per kilogram per degree C. And this delta just means change in, and theta is the symbol for temperature. We don't use T. It might be confusing, but we use theta in this syllabus, and delta theta is change in temperature. So what can you see here? E equals, and we cover up E equals mc delta theta. What does M equal? You've got E on the top and C delta theta below. M equals E divided by C delta theta. C, well, C is E on the top and M delta theta on the bottom. And delta theta, if you want to calculate the change in temperature, then it's going to be E on the top and M C. And remember, you always got to calculate that bottom bit first. Don't do it, just don't stick them all into your calculator, and make sure or at least make sure you're using brackets around the denominator there. Okay, and fundamentally in this lesson now, reasonably straightforward. We're just going to use this formula now to solve a few basic formulas as solutions. So in the next few questions, you're going to need the values that were shown here. So, make sure you've got your booklet open and you're looking at these values. You're going to need these values to solve, because these are all going to be referred to. And let's get ahead with the first one. How much energy is needed to heat up 1 kilogram of water by 15 degrees C? Okay, well, let's start off. Formula. There's only one formula you need for this one. It's E equals mc delta theta. Let's put the numbers in. E equals m. What's the mass? 1 kilogram. What's the specific heat of water? 4,200. You get it from the table. And the temperature change tells in the question it's 15. Let's put those numbers together. And we get 63,000 joules. If you want to, 63 kilojoules will do just fine, but either of those formats is absolutely fine. Question number 2, have a pause of the video. Have a go at doing it yourself. Don't just copy these answers out into your booklet. Have a go at doing them. See if you can get them right before you see the answers. How much energy will be needed to raise the temperature of a 5 kilogram block of concrete by 10 degrees C? Exactly the same as above. E equals mc delta theta. E equals m. This time it's going to be 5 times. If you go back to the table, it's 3,400. Well, the temperature rise this time is 10. Put the numbers in. 170,000 or 170 kilojoules. Either of those, absolutely fine. But don't forget, you have to have the unit. It's not 170,000, it's 170,000 joules or kilojoules. Don't forget the unit. Don't forget to have a go at doing these yourself. Pause the video now and I will carry on going through the answers. Calculate the energy needed to increase the temperature of 100 kilograms of iron by 40 degrees C. E equals mc delta theta. We write that in every time. Put the numbers in. What numbers did you have? M 100, C 450, theta, delta theta 40, 1,800,000 joules, or 1.8 megajoules, capital M here. Don't do them little m, that would be millijoules. I mean a 1,000th of a joule, very different. Have a pause. Let's do the next one. A 20 kilogram concrete block is at 20 degrees C and is heated to 65 degrees C. What is the energy used to heat the block? Sure you've got the hang of it now. E equals mc delta theta. Write it in every time. E equals 20 kilograms. 3,400. Concrete again. 3,400. Go back to the table to check where that came from. And this one, you've got the only slightly trickier bit here is it's not 65 and it's not 20. It's the temperature change. That's what delta theta means. It's the temperature change. So the temperature change is from 65 minus 20, which is 45. Nice and slow. Laid out there. 20 times 3,400 times 45, which gives us just approximately 3 megajoules. 3.06 megajoules. Okay, instead of calculating energy now, we're just going to calculate different things. One question here, we're going to calculate the mass, and then in the other one, we're going to find the final temperature. So, a section of copper pipe is heated from 10 degrees to 31 degrees by adding 13.2 kilojoules. What's the mass of the pipe? We're going to start off as ever with the base formula. Remember the base formula. E equals mc delta theta. Now we've got to rearrange this one. So this is the first one we've got to arrange. We've been asked to calculate mass. So we're rearranging for M. M equals E over C delta theta. Put the numbers in. What's E on the top? Well, E's 13.2 kilojoules. So that's going to be 13,200. The bottom numbers are C, 390. That's the specific capacity of copper. And then I've just done a calculation here in my head. 10 to 31. That's a temperature change of 21 degrees. Must have been 1.61 kilograms. So remember what I said here, you can't do, if you put it on your calculator and you do 1,3,200 divided by 390 times 21, you'll get the wrong answer. So you've got to make sure you calculate this denominator first or use the brackets in your calculator, or else you'll get a different answer. Okay, pause before you do the next one. Have a go at doing it yourself. What will be the final temperature if you used 1125 joules of energy to heat a block of iron weighing 0.5 kilograms with an initial temperature of 23. So we've been told the start temperature, but we've been asked to find the end temperature. So clearly what we need to find is delta theta. Once we get delta theta, that will give us our answer. We need to calculate delta theta first. E equals mc delta theta. This time we're rearranging for delta theta. Delta theta equals E over mc. I need to see this working out in every question. Need to see this clear working out, showing what you're doing. That's why I teach it this way. So it's clear to you what you're doing. So what I'm doing to make it clear. That's exactly what I need to see from you when you're doing your working. What does delta theta equal? Well, the top line is the energy, that's 1125, and the bottom line is MC. MC in this case is going to be the mass, which is 0.5, and the specific heat of iron, if you look it up back on the table, is 450. That gives us an answer of 5 degrees. But is that an answer? No, because we want to find the final temperature, and we've been heating it, and it started at 23 degrees. So the final temperature is 23 plus 5, because this means a 5-degree increase in temperature. Okay, if you can do the questions I've done so far, I think you'll be fine for GCSE. I'll do one more, which is a little bit more synoptic. That means like putting different ideas together. So you're going to need 2 formulas here. I can't imagine anything as complicated as this coming up in a GCSE paper, and if it was, it would really be testing for maybe level 8 and level 9. So quite, even though it's quite straightforward, it's really, if you can do this on your own now, if you can hit pause now and you get the final answer before I go through it, you're quite likely on course for a level 8 or 9 at GCSE. So hit pause and have a go. Okay, a kettle is filled with 2 kilograms of water with an initial temperature of 12 degrees C. The kettle has a power rating of 2.2 kilowatts. Power, The kettle is switched on. Assuming all the energy from the kettle goes into heating the water, what is the final temperature of the water after 1 minute? So, we've got mass, we've got initial temperature, and we've got power. So hopefully, you try and find out what the final temperature is. So we know we're really going to be something to do E equals MC delta theta, but we don't have E. So how can we do it? Well, we have been given power, and we've also been given time. The time was 1 minute. So what do you need to go and reach for? You need to go and reach for a formula that's going to enable you to calculate energy. And that formula is this one. Power is energy divided by time. We can rearrange that to get energy equals power times time. Whichever way you remember that is fine. I'm happy if you write down E equals PT or P equals E over T. But this is the format we're going to need now. So what we're going to say here, 2,200, because it's 2.2 kilowatts, okay, and the time, not multiplied by 1 minute, multiplied by 60 seconds, and that gives us the amount of energy that's going to go into the kettle in 1 minute, and it's 132,000 joules. Now it just becomes like all the other questions we've done this lesson. E equals MC delta theta. Like we just did over the page a minute ago. Delta theta equals E over MC. Now let's put our numbers in. Delta theta equals, there's my energy, 132,000. 2, because we got 2 kilograms, and 4,200. You might start to remember that's the specific heat capacity of water. It's a good one to remember, that number, because it actually does come up quite a lot. It's probably the most common material that you'll work with when you're talking about specific heat capacity. So, if you do that correctly, you'll come up with an answer of 15.7 degrees C. But don't forget, just in the last question, that's not the answer, because you've been asked to calculate the final temperature, and this is the temperature change. That's what the delta means again. The delta theta means temperature change. So we started off at 12 plus that. 12 plus 15.7 becomes 27.7 degrees C, or you could go for 28. I think that 28 would be fine for that one as well. Okay, that's what you need to do for specific heat capacity. Please go through those. Go through it slowly if you want to review anything, and that's good. Thank you for following the lesson, and make sure your work is completed.